Hello and good day. Welcome back to our class. This is teacher Onen Guzman, and our topic for today is simplifying rational algebraic expressions. In this video, we will express rational algebraic expressions in simplest form. Simplifying rational algebraic expression is like reducing fractions in lowest terms. So let us consider this example 6 over 30. Okay, take note that 6 can be factored as 2 times 3, while 30 is 2 times 3 times 5. I can factor out 2 and 2 as well as 3 and 3. So therefore, the lowest term is 1 over 5. Next example. If I have 4 over 12, 4 can be factored as 2 times 2, while 12 is 2 times 2 times 3. I can factor out 2 and 2 and 2 and 2. So what we have here is 1 over 3. We will use the same concept in simplifying rational algebraic expression. So let's consider 15xy squared all over 21x squared y. So 15 can be factored as 3 times 5 times x times y, while 21x squared times y can be factored as 3 times 7 times x times y. So I can factor out here 3, and we have x and y. So what we have here in the numerator is simply as 5 and y. So multiply that one as 5y all over 7 times x. So the final answer is 5y all over 7x. Now let's move on to the next example. So write the rational expression 28x cubed all over 7x to the fourth in simplest form. Again, so we will have our method number 1, meaning to say we will factor all the numerators and denominator. So I have here 2 times 2 times 7 as the factors of 28. Then we have x times x times x as a factor of x cubed. Then we have 7 times x times x times x times x as the factor of x to the fourth power. Okay, so I can factor out here 7 and 7 as well as x and x. Okay, a pair of x and x and another pair of x and x. So what we have here is 2 times 2 all over x. So the final answer is all over x. While our method number 2, meaning to say, I'll simply get the greatest common factor between the numerator and denominator. So take note that 28 can be factored as 4 times 7x cubed, while 7x to the fourth power can be factored as x times 7x cubed. I'll remove the greatest common factor, or factored out the greatest common factor of 7x cubed. So 28x cubed all over 7x to the fourth is equal to 4 all over x. So whichever method that you will use, you will arrive on the same answer. Okay, let's have another example. Write the rational expression 3f minus 12 all over 5f minus 20 in simplest form. So again, we will find the factors of 3f minus 12 using the greatest common factor. So we have 3 is the greatest common factor between 3 and 12. So again, to get this 3 times f minus 12, so 3f divided by 3 is equal to f. 12 divided by 3 will give us 4. Similarly, so I have here 5f divided by 5, so I have f, and 20 divided by 5 equals f. So again, so I can factor up f minus 4, okay, since that is the factors using the greatest common factor. So the lowest term is equal to 3 over 5. So this is the simplest form of 3f minus 12 all over 5f minus 20. Let us now consider the third example. So express x squared plus xy plus y squared all over x cubed minus y cubed in simplest form. Okay, observe that the numerator is already a prime number. It means that, okay, a prime factor. So it means that there's no, okay, number that can divide this expression except 1. However, the denominator is actually in the form of difference of two cubes. So the numerator is simply as x squared plus xy plus y squared. But take note the denominator can be factored as, okay, binomial and trinomial. So again, so to get this x, we will get the cube root of x cubed, which is x. The cube root of y cubed is y. Since this is subtraction, okay, we will write here subtraction as the sign in the binomial. Next, on our trinomial now, so we will have x times x, so we have x squared. Then y times y is equal to y squared. Next, the middle term is x times y is xy. We will get the opposite of the sign in the binomial. So that's why we have positive xy. So we factor this using the difference of two cubes. Take note, so the numerator is x squared plus xy plus y squared. And I can factor this expression and this expression. So leaving the numerator as 1. Okay, so therefore, the final answer is 1 all over x minus y. Let us consider another example. Reduce a cubed plus b cubed all over a squared minus b squared to simplest form. So what we're going to do is, again, analyze what type of factoring method that we can apply to a cubed plus b cubed, as well as a squared minus b squared. Now, observe that I can factor the numerator using the sum of two cubes. And our denominator is I can factor that using the difference of two squares. So let's have here, let's recall. So here, this sum of two cubes can be factored as a product of binomial and trinomial. So again, to get the binomial, so we get the cube root of a cube, which is equal to a, and cube root of b cube is equal to b. Next, to get our trinomial, okay, we will have a squared. So we have here a squared. Then get the product of a and b, so that is ab, but opposite in sign, so that's why negative ab. Next, square b, so b squared. Okay, next, on our difference of two squares, so get the square root of a, so we have here a and a. Next, square root of b squared is equal to b and b. So again, express this as a sum and difference of the same first and second terms. So take note that I can factor now the expression a plus b and a plus b. So therefore, the final answer is a squared minus ab plus b squared all over a minus b. There are times when you may encounter certain situations where the factor in the numerator is in opposite sign of the factor of the denominator. To solve this, factor out negative 1 such that the factors will become equivalent. So let us consider this example. I have here a minus b, okay, all over b minus a. We want to express this expression in simplest form. Again, so we have a minus b all over b minus a. So what will I do is factored out negative, meaning to say, if I factored out negative here, so negative 1, put it outside. Then get the opposite of positive b as well as negative a. So that is why we have negative b plus a. So we have a minus b all over negative 1. I'll interchange now negative b and positive a using the commutative property of addition. So I have here a minus b. So I can factor out now the expression a minus b and a minus b. So I have here 1 all over negative 1, or this is equal to negative 1. Let us consider another example. If I have here 3y minus 9 all over 12 minus 4y. So again, we'll start from the given. Take note that I can factor 3y minus 9 using the greatest common factor as well as the denominator. I can factor this using also GCF or greatest common factor. So the common factor between 3y and y is 3. So the factors are 3 times y minus 3. While in the denominator, I have here 4 times 3 minus y. Observe that, okay, y minus 3 and 3 minus 1 are almost the same, except that, okay, it is an opposite. So what will I do is I'll factor out the negative 1 in 3 minus 1. So I'll put negative 1 here and interchange y minus 3. So I can factor out now here y minus 3 and y minus 3. So in the numerator, I have 3 all over in denominator 4 times negative 1 is negative 4, or simply as negative 3/4 as the final answer of, okay, 3y minus 9 all over 12 minus 4y. Okay, so let's have example number 7. Reduce a squared plus 5a minus 14 all over a squared minus 4 to lowest terms. So, okay, by inspection, so the numerator is actually in the form of quadratic trinomial, while the denominator is actually difference of two squares. So again, to factor the numerator, again, let's have the factors of a squared. So we have a, and the factors of 14 are 7 and 2. So these are the factors of the quadratic trinomial, because if you will check, 7 times a is 7a, and a times negative 2 is negative 2a, and added together, we have 5a. While 4 minus a squared is actually in the terms of difference of two squares or dots. So this is, the factors are 2 plus a and 2 minus a. Observe that I have here a minus 2 and 2 minus a. So what will I do is, okay, factored out the negative in a minus 2. So simply put negative 1 and interchange, okay, 2 and a. So we have here a minus 2. So therefore, I can factor out now a minus 2 and a minus 2. So in the numerator, I have a plus 7, while in the denominator is, okay, 2 plus a times negative 1. Or in simplest form, I can rewrite this one as a plus 7 all over 2 plus a, which is actually a negative sign. To summarize our discussion on simplifying rational expressions, we have number 1, factor completely the numerator and denominator. Separate and divide out the common factor or factors if there's any. And number 3, multiply the remaining factors. Okay, find time to answer our exercises on evaluation. Then check your answer on our answer key. So once again, this is Teacher Onen de Guzman. So if you are new here, don't forget to subscribe to my channel and hit the bell icon to receive notifications about my new videos. So thank you and good day.